Good morning, everybody. We are back with day 7 of Advent of Code 2022. Today looks quite challenging, to say the least. Um, Today we are modeling, we're basically implementing a tiny shell, and we're supposed to use our shell to navigate this directory structure and look for small directories. So let's get started. There are two main things we need to do here. The first thing is to actually interpret these commands, and then the second thing is to build up some kind of data structure that represents the file system. And then we can walk the file system and look for the actual challenge, which is to find the directories with a total size of at most 100,000. We could probably do it in one pass, but I think we're just going to model the file system. So we're going to build the file system up, then we'll walk over it and find our answer. So I'm trying to remember how to do trees in Rust, but I think we can get started with something like this. File. Call it a file tree. I'm pretty sure you have to have two things. Well, actually, maybe not. Maybe we can just have an enum file tree, which contains, it can either have a directory, which itself contains a box file tree, or we can have a file like this. Okay, and then let's see, box file tree. We also want to associate names with these, so I'm probably going to convert this to a name struct. Let's call it subdir. File needs to have a name, and the directory also needs to have a name. Okay, oh, I forgot a curly brace. Let's go and turn on electric pair mode. See how we like that. Okay, so there's our file tree. We'll have to add a bunch of convenience methods on this. So generate impl. Yes. Okay, so let's do, I guess, our new method. So we'll have fn new returns a self. And what it does is we're just going to call it here. So I already took a look at the input, and we only do this one time. So basically, when we see cd slash, we can just make a new file tree rooted there. So let's see, file tree new is just going to give us a self-dir with name slash and subdir. Ooh, file tree. Let's see. How can we make this empty at first? I guess we'll just have a none value. And then subdir will be a box new on self. And of course we have to convert this to a string. Okay. So we'll go down here. And I guess maybe we should start parsing. So yeah, as I was saying before, we've got the file tree representation, and then we also actually have to parse the commands. So let's do our old standby line and s.lines. And sure, let's go ahead and just start with printing line. That's always a nice thing to do. Okay, So we gotta think about this. Well, I guess that's not quite true. I feel like we want some kind of struct that like holds a file tree or something, like a vector, but that doesn't seem quite right either. I guess we can just have none. Let's take this off for now. I think what we're gonna do, let mute, we'll just call it ft equals file tree none. So it'll be none to start. When we see a cd command, we need to, well, let's just write it in here. Fn cd, it will take a directory name, and it's going to update our file tree. Oh, this needs to be ref itself. Okay. So, oh, we need some concept. Okay, yeah. This is why. Let's move this to an enum. We're going to call this enum dir entry, because we're going to have the file tree also contain the current position. Because we need to know where in it we are. Is that right? Maybe it is all the same thing. File tree. We kind of want each entry in the file tree to know whether it's active or not. Is that true? Because we can't just like keep pushing entries. We need to be able to traverse it somehow. So how do we represent traversal? It's like, okay, I'm going up. Yeah, I think we do need some kind of wrapper struct. We need some way to get like back to a parent. Oh boy. We need a real tree is what we need. Alright, let's think about this. I mean, we can do it. Let's see. Let me think about this. I'm trying to avoid using an external package. When you look up Rust, trees in Rust, yeah, you always get the game, of course. But you get something like this. Whoa. Let's go look at crates.io. Tree. Oh. Yeah, we don't want binary search trees. We need more like general trees. But let's see if we can figure this out ourselves. So I think we do need some notion of the parent node for when we do, because how do we cd ... right? Like we need to know what our parent is in the tree. Well, I guess we can just add another entry, but then it needs to be like a reference to it, doesn't it? Let's see. Parent, subdir. This needs to have a parent as well. Okay, they all have names and parents. So the fact that these are shared, right, like name, parent, this makes it kind of look like it should have, wait, we need to have some other struct that contains this thing. So why don't we go back, let's make... I'm just really trying to think about this. I actually thought about this for a little while before starting the video, but as is typical, when you start writing the code, the real problems you face start to emerge. Let's see. Maybe we can have a struct file that has a name, because this is shared. Like, we're always going to have this name. We're always going to have a parent. Now, what is the parent? A parent, I think, is another... I think a parent needs to be... Let's call this... Let's go back to dir entry. I think the parent... The parent is actually an option dir entry. Well, no, I guess if the dir entry can be none, then that takes care of that. Parent is a dir entry. So we've got a file. Its parent is a dir entry. It is itself a dir entry. Okay, but we can get rid of, now we can get rid of name and parent from these. So directories have subdirectories. This doesn't have to have a name or a parent. It does need to have a size. Well, no, then these are all going to have sizes as well. Size. Well, actually, I think only files have sizes. That's what it says in the description. So this is a size, which is a U size. Okay. How does that look? So a file has a name and a parent, and it does also have a type. Dir entry. Then somewhere we have to put dir entry inside a file, in addition to the parent. Because I want to be able to walk up and down the tree, is what I'm trying to figure out. May have to grab my book, my programming Rust book. Because I think they do an example of a tree in here. Tree. Traits. Trees. Uh-oh. It's only listed on one page early in the book, so that's a little frightening. Trees. Okay. Alright, I guess we're on our own. I don't see any trees in here. Okay, well, at least we tried. File. Okay, so we've got files. They have names and parents. Where the parent is optionally none for the root directory. Yeah, maybe we just have to start parsing and see what happens. I'm concerned about matching on dir. If it equals this, I'm just wondering how we go up the tree. Which is why I added this parent field. So that's a special case. When we hit ... we do that. If it's anything else, we need to check. Yeah, we need to know like where we are as well. Like we need some concept of like the current node in the tree. So we have a current node. Well, maybe child. Okay, maybe it's something like this. Something like this. Okay. And then we can just hold the current file. Okay, I think that makes sense. So this doesn't make that much sense. Well, maybe it is on file. Ref me itself. Dir entry. Dir entry. No, the children. Okay, a file has a name and it has a parent, which is a dir entry. It also has children, which are dir entries. But all right, so what I'm thinking right now, if this is a method on file, right? So let's say a file, we're gonna have like our current file here. Okay, it has a name. We can even start writing it. So initially, let's say current is a file. Its name will be root. Its name will be this. 2 O's. Its parent will be dir entry none, because it doesn't have a parent. And its children will be a new vector for now. Okay, so that's how it would start. Okay, so let's see. We type ls. We're gonna have to parse ls. When we see dir a, we are going to try to push a onto this children list. Okay, that's fine. We see a file, we push that onto the children list. We see another file, push. Okay, I think the trouble arises when we see A. We CD into A. Because we're now trying to CD into one of our children. And now the child itself needs to be a file. It shouldn't be a dir entry. Yeah, that's the issue. Is that as soon as we try to CD, I want to go into parent and child need to be the same type as file, so that we can call when you're going to call CD on the file to go either to its parent or to one of its children. So these all have to be the same type. But it feels like we need some kind of structure outside to hold all of the files, so that we can like traverse this like parent-child relationship. Can you do this? Or will it get mad about it being infinite size? I guess not, because the vector is heap allocated, right? Okay, its parent is a file, but we need somewhere for all these files to live. Okay, now it has infinite size. Parent is a file, and the children are files. So this has to be box file. Okay. Let's see. But now it still doesn't have a parent. Oh, maybe it's just an option. I think it says the option box file. Yeah. Oops. Okay. Because some files don't have parents. Now, where do we use dir entry though? Oh boy. It's kind of looking, we're like re-implementing dir entry down here. Because I was about to add a size field here, right? Where directories have no size. But it's like, okay, the size, it'd be nice to have an enum that encapsulates that. We go to struct file. It has a name. I felt like I was making progress when I was talking through the parser. So let's try to do that. Let's start writing the parser, and we'll come back to that stuff. All right. So let's take a look at this. When we see if line begins, I thought it was starts with. Yeah, starts with $. It's a command. So, split white space. And let's try taking the int. We'll take the first one, because that's the actual command name. This could be a character. And we can just debug command. So let's see. How many commands should we get? We get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Great. So we found all the commands. And then I guess we'll just match on command. So it looks like all we have for now, cd and ls. Sure. Unrecognized command. Great. Not yet implemented. Right here, line 32. Okay, so when we do cd, we want to call some kind of cd method. So I still think we want to have some kind of current thing. So when we see cd, we need to try, let's actually do, does this advance the iterator? Be consumed. Also, we'll return different elements. Okay, great. So let's make this so we definitely get a command. Now, if we do cd, we'll say let dir equal sp next unwrap, and we'll just do print line cd dir. But we'll wrap this up, and this needs to be mutable. Great. So we cd root, and then we try ls. Okay, if line dot starts with this, and in this case we'll just say in ls true. So we'll come up here, let mute in ls equals false. If in ls else if in ls, let's just print line. Okay, so we cd slash dir a. Great. So that looks pretty good. We took care of cd and ls. Cd list. Those are the only two commands. Now we just need to work on our, well, yeah, that was easier than I thought. So now we just need to work on our directory representation. I might need to draw some pictures or something. Probably gonna end up cutting some of this stuff out of the video when I'm just sitting here thinking. Okay. When we see a CD, we want to let's try to build it up from the ground. So I'm just gonna delete all of this stuff. We were maybe on the right track, but I'm not sure. So what I want to be able to say, I'm just going to write what I want to be able to say, and then see how we can implement it. So let's have, we know it has to be mutable. We're going to have some kind of file tree. It kind of makes sense to use a vector, I think. Yeah, maybe we can just use a vector. Okay. So, CD. So yeah, if we're just gonna use a vector, then we can just have like an index into our vector, right, for the current element. And then yeah, each of the elements can be a tree itself. Like it can be another vector. Okay, so let's try this. FileTree new. Okay, struct file. Let's call it a file tree. It has a files, which is a vec of something, and it has an index, which is just a pointer into that vector of somethings. Okay, maybe this is a vec of dir entry. Oh no, it has to be a vec of file trees. And then let's have an enum file type. Vec of file trees. We can have directories. I think this is how it works. Like it has to be, it's like mutually recursive. So I think we can have a dir, and we have a file, and files have sizes. What do dirs have? Directories have, it's a vec of file type, where dir can hold a file tree. Okay, I think this is how you do trees. They're mutually recursive. So, s.lines. This gives us an iterator, right? Okay, if line dart starts with this, cd, if dir equals so basically we always start with cd slash, right? If dir equals this, then we can derive default on this. Derive default. Let mute file tree equals file tree default. File tree equals file tree default. Is that right? I think that's right. And we need to have a name somewhere. A file tree. I guess it should have a name. No. These are supposed to just have names. Yeah, I guess we don't need to reset it to default. I guess we just always push something. And I think this does FileTree. Ah, no, no, no. When we add a directory, we'll just push the default to it. Well, this shouldn't have. Oh, index, index, index. No, this needs some concept of like being active. And we're still gonna need. Ugh, this is so confusing to me. Sorry if you guys are very bored here. Okay, so I think when we get this directory, we want to go in here. So we want to do it. Let's impl FileTree. Okay. So we're gonna have fn cd. It takes a refme itself, and it takes a directory name. Okay. So this will change to a directory if it exists, or create it and cd to it. Okay, so the first thing we need to do is check if a directory exists with that name. So we'll look at the current position. Yeah, we need to look in children. This should be called children. Children. Okay, so for child and self.children, if. See, this is why the name thing. Let's do. We can impl this as well. Fn name self. Can you do that? There we go. Great. If child.name equals dir, then, oh boy, for child and self.children, oh god, then we're, oh no. Okay. So it kind of seems like we should have, oh no. It still feels like we need one level higher in the hierarchy so that where we can actually do this like index change, right? I know this is what pointers are for. I'm just scared to try to use pointers in Rust. And because then we're gonna have to try to make sure that we're still gonna need that like higher order entity to hold all of the actual data for the file tree. Because if we're handing out pointers, we have to make sure that this lives long enough for our pointers to be valid. Right? So this is all like wrapped up together here. Okay, if child.name is dir, then we want to cd to that child. cd to that child. Yeah, we need to borrow this. Let found equal false. Found equals true. If we make it through all the children and we haven't found it, then create child and cd to it. Okay, but like, what does it mean to change the directory to our child? It basically means set self to this child. So this child is a reference to a file type, which means we can't set self to it. children is a file type. I guess these don't have to be referenced. We're doing something like this. Okay, yeah, what does that mean? I don't know. We just need some concept of updating the current directory. So we take the directory, we need to somehow push it into our directory tree and update our current directory to that. Push it into our tree, update the current directory. CD, what does this mean? How do we CD to that child? Is this what a box is for? Well, it should be unreachable to do. It should really panic. Like, oh, I messed up. File type none. Okay. Okay, so now hopefully we can update the pointer to the current. So now, hopefully, maybe we don't even need index then. Current box file type. Oh, geez. Oh, geez. Count equals true. Cur. Yeah, self.cur. Child. Maybe we can get away with just, maybe we can use a regular reference. Lifetime, great. Because obviously, yeah, we need tick A, child. Because I guess, yeah, because the children are contained inside of us, right? File type. Oh, great. Okay, we don't have default anymore. Great. Oh no, and now this is, oh. Take A. Lifetime. Now this, we don't care about it here, I guess. Oh my goodness, file type. Yeah, it just cascades. Look at this. It just cascades. Maybe we need to make them static. It's just like, alright, it just lives the whole time. Alright. So we can give an empty vector. Yeah, this is, it needs to be like a raw pointer so that it can be like a null pointer. Well, I guess it can be none? I really don't know. Let's just build one here. See how it looks. So children is fine. It can be vector. It can be empty vector. no problem. This, however, I guess this just needs to be a file type none. Let's try that. Okay, that's fine, I guess. Now, why can't I loop over this? Lifetime may not live long enough. Let's try taking this off. Child. Now I can borrow the child. Okay, yeah, now I can't move out of this. So oh, maybe I just have to say this. And this is tick A. Yeah, this is a nightmare. Oh, okay, it's not that bad. Great, so we can just do this. So we set, this is what it means to CD to that child. Oh. File type. Oh. No, the directory I think needs to hold the children. Yeah, we need to look at self.cur.children. Self.cur.children. I see. Self.cur.children. So we look at the file tree. Okay. I see. I guess we're supposed to match on self.cur. If it's a directory, okay, now the directory, yeah, this children thing really doesn't make sense. I think children go, but we need this vector here. Okay, I think this doesn't need to be a file tree. It can just be, yeah, because it doesn't have any concept of current, right? Yeah, we can just take this out. We'll call this children, which is a box file type. Okay, we can get rid of this tick A. We can get rid of this tick A. We can get rid of this one and this one. Okay. Children. Okay. Great. So now, okay, we're looking at the actual current file, which makes sense. If it's a directory, then we do this. In children. Oh. Oh, we need some kind of box vec file type. Oh, now we don't need the box. Right? There we go. Okay. Can I format that? Great. File type dir. Great. Great, 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 great. Okay. This doesn't exist anymore. If the current directory entry is a directory, we walk looking at the children for child and children. If child.name is dir, cd to that child, so self.cur becomes child, and we say found. Okay. If we don't found it, if not found, oh no, let me undo that. Now, if file type is none somehow, I think we leave the to-do here. But in this case, the case of it being a file, oh, no, this should be to-do as well. Current has to be directory here. Has to be a directory. current has to be a directory at all times, I think. Okay, so if we didn't find it up here, oh, does that mean I can just return? Yeah, we can get rid of this, and we can just return here. So we found it, we go to that child, and we can also, I think we can also have a parent here. And okay, we gotta put our lifetimes back in. Let's see. Take A. Tick don't care. Now what's wrong with this? It's gonna say it doesn't live long enough. Oh no. Okay, parent. But I think we don't care. We don't care about the parent here. We only care. Oh. I'm trying to think about this like a real directory listing, right? Like the children actually contain a reference to the parent, right? Like ... So we could mirror that actually, where the child, yeah, one of the children could actually be a parent directory. I guess we should do that. If dir equals ... then self.cur. But shouldn't they all have parents? Maybe they should all have parents. Yeah, so maybe parents should be here. Yeah. Okay, let's undo all of that. Return. Okay, so we've got a current and we've got a parent, which is also a tick A file type. If dir is this, self.cur is self.parent. Now, okay, I see the issue with this. What's the parent? What do we update self.parent to? Right? So we just moved our current to the parent, but now we need to look at parent and see. Now we need to look at parent and see that. Okay, so it's just this situation. I put undo tree back in. So let's go back this way, because we actually do need to look at this. We need something more like this. Self.cur equals parent return. I think that's fine. Okay, so now if it's not found, then we need, yeah, well, let's leave the comment, create child and CD to it. Self.cur yeah, it all has to be in here. Child and children. Okay, so we didn't return. We didn't find the child. Didn't find the child. Create it. So in that case, we're going to take children dot push a new child dir file type dir the parent is ooh. What is parent? Parent is supposed to be ref tick A. Parent is self.cur. Okay. This is a little touchy because I think we're... Ugh. Let's see. I think we're mixing our reference types here. The name is dir. And children can just be a vec new for now. Vec new. To own. Does that work? That appears to work. Cannot borrow. Yes. Okay. So our lifetimes are messed up somewhere. Yeah, because we mutably borrow it here. Oh, wait. Where's the dir? I think for some reason... This has like a... I might have to specify like a different lifetime here. Does that help? I guess it doesn't help. I'm borrowing it mutably here. I think... Yeah. Okay, FileTree.cd. Cannot borrow FileTree is mutable more than once at a time. Yeah, this is the disaster. So yeah, I think we're running into trouble probably right here. Because we're pushing a reference to self.cur. But self.cur. Yeah, right. We can't borrow children. Yeah, because children is like an immutable reference. Oh, man. This is a mess. Didn't find the child. We have to create it. Its parent is self.cur. Ugh. Yeah, so that's the first issue, obviously. Can't borrow children is mutable as it is behind a ref reference. And then, of course, we can't do this because we still have it borrowed here. Ref tick A. I think I might have some of these references wrong. The lifetimes. We have it borrowed for tick A. Ouch. This is a rough one. This is a rough one, for sure. Tick A. FileTree, tick A. Yeah, because I'm trying to take references to myself in here. Does children need to be like a cell or something? File type. Yeah, I think the issue, parent is a reference to a file type. God, this is a mess. Why did I think I couldn't put parent on this? I think if we had the parent in here, it would be okay. I mean, maybe current just... No. Huh. Children is a reference to the data it refers to. Yeah, but that's not even the main problem. This is the main problem, right? Is that we can't borrow FileTree mutably again. So we can't... I think, okay, it's because this tick A, this reference, the lifetime of the reference on self is this long. Oh, okay. Yeah, I just had the wrong lifetime here. So this tick A is corresponding to this. These are just tick others. Yeah. This one doesn't even matter. Let's say tick self. Can I do that? No, apparently not. Tick O is apparently fine. Now this one, we don't even care about this one. We just need to make sure that it's not A. Okay. Okay. So why is this giving me self.cur is a ref mute? How do I get a mutable reference? Can I do that? I don't think so. Children is a mutable reference and match. I think you can, right? Let's see. Yeah, I thought you could do something like this. Move occurs. Cannot borrow is mutable. Cur. Oh. Oh my. Does that work? No. Well, it might be possible though. Type differs in mutability. Okay. Line 40. Parent. Okay, now this doesn't look good. Can't borrow is mutable. Because cannot borrow parent. Oh, geez. Lifetime defined here. Okay. Child is not declared. Oh, okay. Well, we could probably fix that one. Children.iter mute. This is a disaster. Hey, little dog. Cannot borrow. Child is mutable. It's not declared as mutable. Oh, God. we gotta cheat. Let's see. Let's look at this guy's blog. Wow, that looks crazy. Back node. Parent. Previous. Next. First. Last. Node ID. Okay, you do have to have 3 layers. A memory arena. Okay. Oh boy. I'm still recording. I'm going to cut a bunch of this out. There's no way I can post this whole thing. Yeah, this makes a lot of sense. Yeah, this totally makes sense. Alright. So, alright. We're going to have a file tree, which just contains nodes. Let's put it in here. Nodes, just a vec of node of t. Let's just say, we'll just have a tree, vec of node of t. This is generic over t. No, we don't need to make it pub. We can have struct node t, which has a parent option. We're just going to go for a usize. Parent, children, that usize. Vector can be empty, so that takes care of the option. And then data is a t. And in our case, our data will be file type. So we can get rid of this, get rid of this, directory. The children is handled outside. Files have names and sizes. And I guess this could be none as well. So we can get rid of this. That really wasn't so hard, was it? Parent, children. Okay, let's get rid of this. Get rid of this, get rid of this, get rid of this. Vec node. I feel like I was close to this, but just not quite there, huh? Parent node. New node. Does the node doesn't need to know its own index? I guess not. Maybe this is a file tree. Okay. Nodes, parent, children, data. Okay. This is a refster. Okay. Match. So we take a file tree Oh, why did I call it tree file? File tree. We've got ref mute self, and I think we do want to have a current, the current index, right? And we can just get rid of these t's. These are just nodes composed of file type. Oh. Okay. And we'll call these files. Back a file. Okay. Self.cur. We need to match self nodes of self.cur. Okay. Dir. Whoops. What does a directory have? See, this, I was trying to put the children inside of the directory. I guess we can do that actually. So this has children. And files don't have children. Okay. Expected struct file found enum file type. Okay, there we go. So we match on file, I guess this should be called type. Self node, self.cur type. If it's a directory, it has to be a directory actually. We extract the name of the children. If there is this, self.cur equals self.nodes of self.cur dot parent unwrap and return. Otherwise, for child in children, child is a U size. If children is a U size, is a vector. Okay, great. If self.nodes of child dot type dot name equals dir, self.cur equals child, return. Otherwise, self dot. Okay, so we have to create a new node. We need a new file. Didn't find the child, create it. Let me just go over here. Alright, we're in a directory. Name children. We're not going to care about name, but we don't know that yet. If there is this, then I set current to self.nodes of self.cur.parent.unwrap. Great. For child and children, if self.nodes of child.type.name is dir, then we set cur to that child. Otherwise, we need to create a new node. So self.nodes is a vec of file. So we need a file new. Self.nodes.push. Let's delete all of this. File. Parent is self.cur. Create the child. So we're going to make parent is sum self.cur. Type is a file type. dir. Its name is dir2 owned, and its children are currently unknown. So this will be a vec move. Didn't find the child, create it, and then cd into it. Actually, we can even do this, right? Self.cd. Here. That should work. Okay. So let me FileTree. Will be FileTree. Nodes is a vec new. And cur is none. Right? Oh. Ooh, that's not gonna work. Can't move out of this. Do I do this? That's fine. Now I have to dereference all of the children. And we don't care about name. Yeah, whatever else. Okay. I think current maybe should be... Let's try it. Yeah, index out of bounds. That's what I thought. Because we go straight for cur. Match. Okay, so if it's not a directory... If it's none... Ah, okay, sure. Should only be true at the beginning. So create root directory. File type none. Then I think we should do something like this. Oh, actually, hold on. I guess we can just move this stuff out here, right? Oh. Ooh, we recursed too far. Self.nodes, file can't be formatted, derive, debug. Okay. I don't see why this doesn't work. Self.cd dir. Return. Yeah, it's just recursing over and over. What's going on? There's that push. Oh, I never updated self.cur. Is that right? No, something like that. Alright, so we are in here. So we get in here. I match self.nodes. Now we must never come in here. Yeah. Okay. And we never come in here. Okay, so maybe we're not updating children. Children equals vec new. Self.nodes. We've got a file. Parent is sum 0. Oh, wait, no. Parent should be none. Parent should be none. No, I see. Okay, hold on. Parent. Yeah, okay, hold on. Well, let's keep the debug stuff. This should be to do as well, I think. Let's put this back over to here. What? No, I guess this does have to be out here. Okay, there we go. We're recursing like crazy again. So, why is it not entering this? So the first time we come in, we make nodes this. We add a file with no parent. It's a directory. Its name is this. It has no children. Okay, and then I call cddir, which should say this should be good. It should be a directory. So I can say print line in here. Oh, it's because it's not the children. Or it's because it's not the child. Oh, I see. If, we do want name. Name. We're already in there. Great. So we add a. Oh, okay. I think we're in business now. Yep, we got a. Ooh, we added a twice. Yeah, I think maybe we don't want to do this thing. A. Oh no, is it doing it again? Okay, I think the recursion is just bad. Let's not do this. Self.nodes.push. We created the file, and then how do we cd to the file? We set self.cur equals. Does this return anything? Yes. Whoops, line 40. Parent, how does that happen? Alright, so initially it's empty. We push this in, cur is 0. Okay. nothing. We add a. Current is a. Great. Okay, there's a. Then we do ls. Now we should get CDE. Current is 2. Ah, we're not updating children. I see. Children. Ah, before we set cur, we need to say self.cur.children. Okay, yeah, this has, let's go back up here. Yes. Children. There. Self.knows at length. So we'll just take this. Knows at length. If in. So we just pushed one of these. Before it was -1. That is -1. Children. Okay, mutable borrow. Oh, I see. Okay, that's fine. I think we're just gonna have to. Actually, I guess what we should do. No. This needs to go back out here. Alright, what we're trying to do, we need to update the children, is the issue. Yes. So we did this for that. To do update children. That's why it's not working right now. It's because we haven't updated the children. Update children. Knows at length. Otherwise we come out here. Okay. So I need to take I guess we have to do this again. Match. Here we have to do it mutably. Self.nodes, self.cur, type, file type, dir, children.push, in. -1. Let in equals self.nodes.length. Okay. Now, what's the problem here? Oh, yeah. is not mentioned. Yeah, it has to go at the end. Fine. Alright, let's try that. So we've got... Alright, let's only print this when we CD, actually. Debug FileTree. Okay, so first time we CD to root. Great, there's our file tree. Then we get A, current is 1. Then E is a child of A. Children 2. Children 0. Oh. Ooh. Children should not be 0. Children should be... Yeah, we're saying it's a child of itself. That's not right. Yeah, that's because... we need to think about this one more time. Self.nodes.push. Parent equals none. Why are we saying the child? I mean, it can't be a child of itself, right? Push n minus 1. Children. We're pushing to the children n minus 1. If self.nodes.length greater than self.cur. Yeah. Let's try that. That's a little goofy, but it'll work, I guess. Children is 1, which is A. Children of A is 2, which is E. And then this happened on line 40, where we unwrap the parent. Why is that? Oh, because I'm not updating the parents. Parent. Where's parent? Struct file. Which one doesn't have a parent? Oh, I'm not setting the parent. Parent. If self.nodes.length is greater than self.current. Okay, I see. Hold on. So let's just do this. If file type is none, well, no, this is the same. Self.nodes. I'm going to a lot of trouble. Wow, this is a ridiculously long video. I'm going to a lot of trouble just to do the cd slash. Yeah, let's just do this. All right, take this off. Take this off. If dir equals slash, just set self.cur equals 0. Parent and return. Self.cur is 0, return. And let's go to FileTree. Impl FileTree, fn new, returns a self, self nodes, vec new. Oh, it's not vec new, it's vec file parent none, type is file type directory, name is root, children vec new. Let's try that. Missing cur. 0. Okay, so this is a new file tree. So if dir is this, self.cur is 0, return. So this should be to do. This should always be okay. Parent should be self.cur dot unwrap. Wait. Whoops. Some self.cur. There. Does that work? Panicked index out of bounds. The length is 0, but this is 0. 52. Oh, right, because I forgot to call, yes, equals FileTree new. All right, there we go. Okay, we've got our file tree. We've got E. Now we're supposed to CD up twice. CD up, CD up. Now we should add D down in here somewhere. Yeah, here's D. No, is this D? Cur is 0. That's right, out of E, out of A. Current is 0. Then we CD into D. All right, that looks good. That looks good. Okay. Okay. In ls is true. If we're in ls, if not, line dot starts with dir, we are going to add a file. FileTree dot add file. FileTree add file f. Generate the method. Let's go to add file. Ref needs self. Takes the file name. Doesn't return anything. All it does is it self.nodes of self.cur file type dir this equals this, else panic. We're going to reference it. Okay, great. Why is it like that? The formatter doesn't know about let else. All right, we've got name and children bound now. Fantastic. So we're going to take children. Oh, this needs to be ref mute, I guess. Children dot push. Oh no, we need to add a new node. Is that right? What is a node? File. We need a new file. I see. So we push a new file. Parent self.curt. Type is file. Type file. Name is f.toOwned. Size is, oh, we also need to give it a size. So we push a new node. We take children. We're going to push self.nodes.length -1. I think that's good, right? I think that should be right. We should just collect this. Vec let size equal SP. This will be SP1, and the size is size. SP0.parse. Now it should be able to infer the type here, hopefully. Okay. Go away. And it's going to say I can't borrow it here. First we'll borrow is up here. Okay. We have to do this first. Children.push. Field size will be read later. None is never constructed. Okay, fine. We'll get rid of this. Who cares? Because we got rid of none. We got our file tree. We've got sizes in here now. So now we just need to walk the file tree. Why is this so bad? All right, we've got our file tree. Stop printing the file tree. Let's just print it once at the end. Yes, I understand it's never read. All right, so our file tree here at the end. We've got root. Its children are 1, 2, 3, 9. 1 should be A. Uh-oh. Well, that doesn't actually look right, does it? Because this is now... What the heck? Children. 1. Isn't this supposed to be... Shouldn't this be 1? Parent is 0. they there? Oh, no, that's right. Oh, okay, okay. No, I was thinking these would be A. No, these are his children. 1, 2, 3. And then D should be 9. Is that 9? Let's do 4 node in FileTree. Print line. Let's do I comma node in FileTree.iter.enumerate. Let's give that a shot. Okay. Yes, so 0 is our root directory. Children of that are 1, 2, 3, 9. So it should be B, C, A, and 9, which is D. Okay, that looks right. These are files with the right sizes. Yep. A has children 4, 5, 6, 7. 4, 5, 6, 7. A has children. E, which has child 8. I, yes. F, G, H. Wow. Okay, I think it's working. This is incredible. Okay. Now, we need to walk the tree. You need to determine the total size of each directory. The total size of each directory is the size. Okay, so we go into here. Print line node.size. And of course we need to do this. Size. Where's my size method? What? No code actions. Node is a file. How do we get the size of a file? Well, okay, file. Do I have an impl file? Impl file. Why is this here? This should be up here. Fn size takes a self. And this just returns usize. Self.type.size is what it returns. Its size takes a self. Usize. Match self. If it's a file, just return size. Otherwise, we're going to come in here and children dot iter dot map I see. They're just U sizes. Okay. So we have to do this. Oh, we're going to actually have to do size on FileTree. I see. Alright, well, undo this then. Well, we can kind of keep this. So this actually can't be size. FileTree, we need to put size in here. Takes a self and an index. And this returns a usize. So in this case, yeah. So we have to walk self.nodes. Node and self.nodes. It's a file. We're going to match node.type. If it's a file, then we can just do size. And if it's a directory, then for child and children, we have to call self.size on child. And we have to add those up. So let's do children.iter.map c self.size of c dot sum. That's what we'll return. File not covered. File's covered right here. Some usize. I'm a bit confused here. Let's see what's going on. Oh, I just gotta compile it. No method size found for ref usize on line 20. Oh, geez. Okay, expected usize found reference usize. I hate this stupid fly check thing. God. Expected usize. Oh, geez, come on. I guess it's cooler to put it over here, right? This is found to be of type. What? Why is this unit? Oh. Yes. What's wrong? I'm so confused. Why is this unit? Shouldn't some... Expected usize. Standard iter sum. Self.size returns a usize. This is size. Children is a vec of usize. This doesn't make any sense. And children 0. Does that satisfy you? Oh. I'm an idiot. Okay. Yes, for node and nodes. Wait, why am I doing self.nodes? No, this is just wrong. I see. Self.nodes of IDX dot type. Okay. Print line node dot size. Yes. FileTree dot size of I. There. Consider borrowing here. 33. So we borrowed, now we have dereference. Okay. Okay. Oh, this has gone on way too long. I am horrified about the second part. Okay. So we actually, and we only care about directories, of course. Generate is method. Okay. 584, 94853. These are the right numbers. Holy moly. Okay. Let size equal if size less than or equal to this. We do this. Okay, we get 2. We add them up. Whoops. Okay, does it work? 95437. Let's try it on the input. Oh my god. That's the right answer. Okay. Now, we're ready to choose a directory to delete. The total disk space is this much. We need this. We need to find a directory we can delete that will free up enough space. The total size of the outermost directory, size of the unused space, must be this, which isn't quite this. Therefore, okay, delete E. We want to delete the smallest directory. Okay. So this is the total disk space. Okay, we gotta commit that. Whew. That was pretty brutal. Okay, now this part, not too bad. We have our directory tree. Wow, that's crazy. Okay, we've got our directory tree. Now we have the total space. The total space. All right, const max use size is this. Let cur be FileTree dot size of 0. We need to know what is max Oh wait, hold on. You need unused space of at least. I don't think we need this. We don't actually need this one. We'll call this need is this much. Current is this. Let want is the difference. Oh no, I see. Const max usize. Okay. Cur used. Let's do cur avail is the difference between max and cur used. So what we want is the difference between cur avail and need. Debug one. Let's look at the sample again. Whoa, I got something backwards. 146. Cur avail is max. Need. Oh, okay, sure. Let's try that. 95437. That doesn't look right. No, that is right. The size of the unused space currently is this, which isn't quite enough. That's 84,000. Oh. No, something's wrong, I think. Yeah, this is... Oh. Oh, I wasn't looking at the right thing. Okay, that's good. That's good. Yes, so one is correct. So we want to look for the smallest directory. What is the total size of that directory? Okay, so we want the smallest directory node type is directory. Okay, FileTree nodes iter enumerate dot map I, node. So this is going to be a flat map. Muters. What's this? This is supposed to be like this. Great, so that's dirs. Debug dirs. If node type is dir and if okay, let size equal this. If size greater than or equal to 1, some size else none. Okay, so that will get us the ones that big, and then we can sort them. Sort debug dir. That's fine. And we'll take this one. No. The total size. Oh, that's because I ran it on the sample. Oh, jeez. I'm surprised that hasn't happened before, actually. I wonder if it's going to make me wait. Okay. 37 seconds. Okay. Well, I think this should be right then. Okay. Well, 8 seconds. 5, 4, 3, 2, 1. Hopefully that's 8. Let's try it. Yes, that's the right answer. That was brutal. We got our stars. Have a nice day.